Hello, this is Mrs. Garple, and in this video we are going to go through the process of completing the square when the quadratic equation or quadratic expression is not a perfect square. Remember, in order for it to be a perfect square, if we have ax squared plus bx plus c, then c is going to equal half of b squared. If I look at this equation, my b is 8, half of 8 is 4, squared would be 16. So this is not going to be a perfect square. The process is this: we start out the same as if it were a perfect square. I see that I have x squared, so I'm going to build one block that has a square with dimensions of x by x. I'm going to take the b value and divide it evenly to my dimensions for my block. So I have 2 dimensions. I need to divide 8 over 2 dimensions. That means I'm going to add 4 to each dimension. So now I have plus 4x and plus 4x. I'm going to forget about the 10 for now, and I'm going to find the units that would complete this square, hence the title, Completing the Square. So 4 units by 4 units, that's 4 times 4, gives us 16 units. To see what adjustment we're going to have to make, the expression, the equation starts out with 10 units, and I'm going to subtract the 16 to find out what the adjustment is going to be outside of this square. So if I look at this square and I want to write my new equation through the process of completing the square, I have y equals, my square is x plus 4 squared, and my adjustment is going to be 10 subtract 16, which is minus 6. Now that I have written this equation in vertex form, I can identify the vertex, and the vertex is going to be -4, because the horizontal change is going to be opposite what we have in the parentheses, -6. So our vertex is -4, -6. When I look at this next one, again I can check half of -10 is -5. Squared would be 25. Once again, I'm not going to have that perfect square. So I need to start by constructing my block or my square with an x by x square, which is x squared. I need to divide the -10x evenly on 2 sides. Half of -10 is -5, so I'm going to subtract 5 from my x values. That gives me -5x and -5x. And to complete this square, -5 times -5 is 25. Again, to see the adjustment that's going to need to be made, I take a look at my c value that I have, which is -8, and I subtract the units. So now I can write my vertex form: x minus 5 squared minus -8 subtract 25 is -33, so it's a minus 33. This was an equation, so I do need y equals. If I were to graph this, my vertex would be located at 5, -33. We can also do this when we need more than one square. So when we need more than one square, we're actually going to be starting with 2 squares. So what you might want to do is either draw 2 squares or pull a 2 out and make 1 square. Keep in mind, pulling that 2 out is dividing by 2. So I'm going to make 1 square, that's x by x, so I have my x squared. I'm going to have 2 of these, so I need to divide 12 by 2, which is 6, but then I also need to divide that by 2 to give me the 3 that I'm going to have. Now, if you're not quite sure how I got this 3, I'll illustrate it here another way. I can start with 2 squares because it's 2x squared. So we have x by x. And I'm going to have a total of 4 dimensions that I need to divide the x terms, or split the x terms into. Since there are 4 of them, 12 divided by 4 is a positive 3. So we have 3x, 3x for 6x, and 3x and 3x for another 6x. I need to find my units to complete my square. So each square, whether I'm doing the 2 times or I have the individual squares, the unit squares are going to be 3 times 3, which is a total of 9 unit squares. I had the 15 squares to start with, and I need to subtract how many I have in my models, in my diagram. So in this first method, I do have to take the 2 times the 9 to subtract the 18. If I look at this method, where I drew them individually, the total is 18 units. So again, I'm going to take 15 and subtract 18. Either way, what I'm going to end up with for my equation is y equals 2 times x plus 3 squared. 15 subtract 18 is minus 3. And our vertex, if we graph this, is going to be -3, -3. It's just that because we had the more than one square this time, we actually are going to have some stretch on our graph. This method works if the b value is odd. You'll just have decimal values that you're working with. This process will also work if a is a fraction. You're probably going to want to work with this first method, though, if it's a fraction, and divide the first 2 terms by the fraction. And this completes the video on completing the square when the expressions are not perfect squares.